11 and 12 are all about first expressing something as a positive acute angle, and if asked, to find the exact value. For number 10, they just wanted to express as a function of a positive acute angle. So cotangent of negative 110, I rather work with the positive coterminal angle of it, so I add 360 to it to get 250. These two angles are coterminal, but this is definitely easy to work with. So expressing as the function of a positive acute angle, we'll use the letters SFR. S stands for the sine, SIGN, F is the function of the original, and R is the reference angle. Remember, the reference angle is a positive acute angle. It's always distance to the x-axis, never the y-axis. Sorry about that. The answer key was wrong here. I'm going to change that. 250 terminates in the third quadrant, where cotangent happens to be positive. A is for all, S is for sine. That's where everything in the first quadrant is positive. Anything that terminates in the second quadrant is positive if it's sine or its reciprocal cosecant. Anything that terminates in the third quadrant is positive if it's tangent or its reciprocal cotangent. And anything that terminates in the fourth quadrant is positive if it's cosine and its reciprocal secant. So this terminates in the third, therefore the sign is positive, which the answer key was wrong here. Cotangent, the original function, don't change it, and the reference angle, since it's in the third quadrant, we do 250, which is the angle, minus 180, which leads me to the reference angle right here. So I have cotangent of 70 is expressing this as the function of a positive acute angle. They would never ask me to find the exact value of this, because you can only find the exact value of exact value angles like 30, 45, 60, or quadrantal angles like 0, 90, 180, etc. So something might be a hidden exact value angle, but this negative 110 certainly was not. When we get to number 11, which asks me to find the secant of the exact value of secant of 5 pi over 6, first of all, I don't deal well with radians, so I immediately want to change this to degrees. By substituting, pi is 180, so 5 times 180 over 6 is 150 degrees. First thing I have to do is I need to find an exact value angle, and it's hidden. So if I express this as the function of a positive acute angle, I might be able to find a 30, 45, or 60. So 150 rotates to the second quadrant, and that's where secant is negative. That S stands for sine, not secant. The sine is negative. The function is still secant, and the angle is 30 because it's 180 minus the angle to get me a reference angle of 30. So I have minus the secant of 30. Now, I don't know what that is, but I certainly know what minus the cosine of 30 is, isn't it, from the tic-tac-toe chart. It's negative radical 3 over 2. So once I have that, to get minus the secant of 30, I just take that and I flip it. So it becomes negative 2 over radical 3. Now you wouldn't leave it that way because it's not rationalized. You can't have an irrational value on the denominator. So what we do is we multiply top and bottom by that radical 3, because that's not really changing it, that's in the form of 1. We'll be able to rationalize the denominator. So I get negative radical 3 over 3, because radical 3 times radical 3 is 3. So that is the exact value. Notice I didn't give a decimal. A decimal would not be exact value for this. For number 12, it was just the same thing as we did, but 3 pieces. Sine of 225, SFR, terminates in the third quadrant, where sine is negative, function is sine, to get the reference angle, 225 minus 180. That I get right from my tic-tac-toe chart, negative radical 2 over 2. Tangent of 135, SFR, terminates in the second quadrant. That's where tangent is negative. The function is tangent. The reference angle is 180 minus 135, or 45. Get that from the tic-tac-toe chart, is negative 1. And lastly, cosine of pi over 4 is really cosine of 45. Get that directly from the tic-tac-toe chart of radical 2 over 2. So I just bring it back. They wanted this times this minus that. So negative radical 2 times negative 1 minus that. This becomes positive radical 2 over 2 minus radical 2 over 2 is a 0. You can check that with the calculator by typing it in.